Good afternoon. Am I audible to you?
Good afternoon, Mr. Ashlish. Yeah, you're audible to us.
Fine. So we will be continuing with differentiation. I'm just sharing the screen with you so that it will be easier for you to understand. And in the meantime, please be with pen and your copy notebook. In continuation, we had discussed product rule. I'm starting with quotient rule. As you can see, that the problem will be given to you in this form. In this form. That means with a numerator and a denominator. Now, what is the actual procedure for differentiating? You have to square the denominator. Here it is. Catch a line, come to the numerator part, straight away write the denominator, differentiate the numerator minus the numerator as it is into the derivative of the denominator. This is what is known as quotient rule. Now we have a problem like this. It is x cube minus x square plus 1 by x square plus 1. Now what we are going to do? We have to simply square the denominator. Here it is. Write this denominator in the front. Now d by dx of the numerator. Here it is. Minus the numerator into d by dx of the denominator. Here it is. Now, since these are all algebraic expressions, so they can be differentiated in a single step. We will write the numerator, this part as it is. Differentiation of x. So differentiation of x cube will be 3x squared minus derivative of x square will be 2x and derivative of a constant term is 0. So there is no need of writing 0 over there. Now, close the bracket, minus, write this bracket as it is. Now you have to differentiate this part. Derivative of x square is 2x and derivative of constant is 0. Leave 0. You will get this form divided by the square of the denominator. Right? Now open up this bracket and you will get the solution. I'm repeating the quotient rule because we will be using it across many numerical parts. In the many questions and many concepts, we will be using this quotient rule and product rule. Derivative of u by v form problem is, first of all, you have to write the square of the derivative in the numerator, write that part only, multiplied by derivative of the numerator, minus numerator into derivative of the denominator. This is what is written in the yellow box, is the quotient rule. Now we will see another problem that is similar to that. You can see straight away that it is a u by v form. What we will be doing? We will be squaring this part over here, a line, and straight away we will be writing this part into derivative of this numerator minus this numerator into derivative of this denominator part. Right? Now, in the next step, this bracket will be as it is. Derivative of x square will be 2x, derivative of x will be 1, and derivative of a constant term is 0. Bracket close. Minus this part as it is. Derivative of 3x square. Derivative of x cube will be 3x square. And derivative of constant will be 0. Close this bracket. Divided by square of the denominator. Now, open it up. Multiply these two brackets. Minus this bracket. Now add like terms. Subtract and add like terms. And what you get will be the answer. what you have to apply has to be seen in the very first step of the problem. Another problem, you have 2x plus 1 upon x minus 1. What we will be getting, we will be supplying the derivative denominator line. This part will come over here, derivative of the numerator here, minus now the numerator into derivative of the denominator. X minus 1 as it is, derivative of 2x will be 2, constant will be 0, leave it, minus this bracket into derivative of x will be 1, and constant, derivative of constant will be 0. Open it up and solve it. Add like terms and proceed. Is that clear? Have you understood the concept? Because this is what we will be doing it throughout the differentiation. Just have a look at it and let me know where the problem is. Unless and until you ask, the problem will remain the problem. Should I proceed? I'm audible to you. Someone should respond.
Yes, Mr. Ashlish, you're audible. Just keep going.
Okay, that's fine. Just let me know where the problem is, if you have. Should I proceed now? The next part is the chain rule. Normally what happens, if you see in the first line, if hx is equal to g of fx, then h dash x, that means the derivative will be the derivative of g into derivative of this function fx. This is chain rule. But we have to keep one thing in mind, that hx is a composite function. We will see to it what actually that means. Another version of this is, there are two functions, y is equal to hx, which is equal to ux. Then u will be taken as fx. Then your dy by dx, because your derivative has to be in the form of dy by dx only. So you first, what you will be doing, you will be differentiating with respect to u into with respect to x. So mathematically what happens, this du and this du will get cancelled and you will be remaining with this dy by dx. Now we will see how that works. Now see, I'm going to apply the chain rule. This is something composite. Your problem is here. You can see that it is 2x plus 5 raised to the power 4 divided by 5x minus 7 raised to the power 4. What we will be doing? There are two methods of doing it. First of all, it is applying the quotient. What we are doing, what the conversion is, since you can see that the power is 4, that's a big number. What I did, I replaced, because powers are same, I just simply kept this term as u, and the power will be 4. I made it u power 4, where u is this term. Now, I will be applying chain rule. When I'm applying chain rule, so what I'm doing, I'm dy by dx is equal to dy by du into du by dx. What I'm doing, I'm differentiating this only right now. That is dy by du. This is u power 4. That derivative will become 4u power 3. Leave it. Now we have this du by dx. We want this du by dx. This. So that is derivative of this part. Derivative of this part will be, it is a chain rule. This is basically we will apply quotient rule, because this is in the form of u by v. Straight away, du by dx will be equal to square of this term. This term will come in the numerator, and derivative of this 2x plus 5 will be 2. Minus numerator as it is, derivative of 5x minus 7 will be 5. Simplify it, you will get this. Now, go back to the problem. What you have, now multiply this. You can see that there is something with u. What is your u? What is your u? U is your this. Replace this u by this and club all the things. Your answer will be in the form of x only, in terms of x. This is what is known as chain rule. Depending upon the nature of the problem, we can change. And when we are changing the functions, then we have to apply chain rule. Your question was in terms of x. We were supposed to find dy by dx. Since the function was a composite function, I simply replaced this big term by u, and this is u. Then I applied quotient, chain rule. Chain rule is this rule. Normally, first of all, I will find dy by du. That will be 4u3. Then I will be differentiating du by dx. My u is this, and I will be differentiating this. Okay. This is my quotient rule. When I'm clubbing, I'm getting this, but my quotient was in x. So I have to replace this u with x. What is the value of u? That is 2x plus 5 divided by 5x minus 7. Just keep it, solve it. And you can do one thing. You can see straight away, see to it, straight away apply quotient rule to this problem. Don't apply chain rule. If you are going to apply quotient rule straight away this to this, it will become a solution with tedious of calculation, and it will be a problem for you to simplify it. That is why we are using chain rule. Now to the power. See to the power. You have a function. This is what we are doing in chain rule. Normally, later on in the class, we won't be doing. We will be straight away solving the problem. Now you can see this is the basic result. Your function is hx is equal to fx raised to the power n, where n is a real. Then its derivative will be what? Hx will be a derivative of hx will be h dash x, no problem. This power will come in front of this. This will remain as it is. A power will be reduced into derivative of f dash x. This is power rule. Now see how it is applied. You have this function. We have to differentiate this. What I will be doing? First of all, I will be removing this under root from here, and I will be placing a power of 1 by 2. Now, my question is this fx is equal to 3x square plus 4x power half. Now, I will be differentiating it. So, differentiation of fx is f dash x is equal to bring this power in front of it, write this as it is, reduce one power from it, 1 by 2 minus 1 will be minus 1 by 2. Now, and multiply with derivative of this. Derivative of this will be 6x plus 4. Bring this down, take 2 common from the numerator, and write the answer. This is chain rule or general power rule. Again and again, we won't be writing dy dx, we will be straight away doing it. And that can only be done if you remember these basic formulas. Now see, there are two functions. Y is equal to u power 5 by 2. And your u is 7x power 8 plus 3x squared. Straight away, two things are there. But now I'm doing it directly. dy by dx is equal to dy by du into du by dx. First of all, what I will be doing? I will be differentiating this part. dy by dx will be equal to 5 by 2 will come in front. U will be as it is. We reduce this power by 1 by 2. 5 by 2 minus 1 will be 3 by 2 into du by dx. Your du by dx will be the derivative of this part. 8 7 are 56, reduce 1 power, plus 3 2 are 6, reduce 1 power. Here it is. Now, you have to replace this u by this. Replace this. Whatever can be taken common, take common and simplify. It is basically the decision of what to do will be taken after you have a clear concept of the understanding of the problem. We have to find differentiation. This is, you can see that one term is in the form of y and u, and the other term is in terms of u and x, and you are supposed to determine dy by dx. So straight away we will be applying this formula or this concept. Now comes some standard results. As we will be proceeding, so we will be clubbing things. Now see, if you have to differentiate log x, y is equal to log x, dy by dx of log x is 1 by x. That is a standard result. Derivative of exponential function, that is y is equal to ex, dy by dx is equal to e raised to the power x. And if the function is in the form of a raised to the power x, then its derivative is a raised to the power x into log base ea. These are the standard results. Now we will see. We will be applying the concepts of what we have discussed. Now your problem is you have to find dy by dx of the following. Y is equal to log fx square plus 7. Straight away things should click into your mind that this is a function of logarithmic. What we will be doing? We will be just replacing or substituting 5x square plus 7 by u. When we are doing that, our question will become y is equal to log u. Right? Find dy by dx. If you have to find dy by dx, then what you will be doing? What is the derivative of log x? Derivative of log x is 1 by x. Your x, complete x is this one. Complete whole. So straight away write 1 by 5x square plus 7 into d by dx of this. We have to differentiate this function till we get a linear power. Keep that thing. So what will be the next step? 1 by 5x square plus 7 into derivative of this will be 10x. Simply write 10x upon 5x square plus 7. That is the derivative of this problem. Now, if you have another problem, y is equal to e raised to the power 5x square plus 4x plus x. Now, this is a problem of e raised to the power x, that is exponential. Straight away, what we will be doing? dy by dx is equal to derivative of e raised to the power x is e raised to the power x only. This is there into derivative of this because we have to differentiate till we get a linear power. What will be the derivative of this 5x square plus 4x plus 8? It will be 10x plus 4. That's it. Derivative of log x is 1 by x. Derivative of e raised to the power x is e raised to the power x. Now, you can see to the problem, there are two things. Two functions are there. The question is, the first function is algebraic function and the second function is a logarithmic function. That means it is basically a product of two things. If we are talking about product, so we have to apply u by v, u into a uv formula. What is that? We can take this as the first function and log x as the second function. So straight away, first function as it is, derivative of this function, plus this function as it is, derivative of first function. X square will be written as same. Now see, we have log x, this, complete. So we will be writing 1 upon x into derivative of this, plus this part into derivative of x square, that will be 2x. We don't have to differentiate, keep one thing in mind, don't differentiate over here, you have to differentiate this part. So your problem will be now 3x square upon 3x plus 1 plus 2x log 3x plus 7. This is your solution. You have seen product rule in two functions because that is applied in two functions only. Here first one is algebraic and the second function is logarithm. This is what we have done. d by dx of e raised to the power u. That is e raised to the power u into du by dx. d by dx of a raised to the power x. It is equal to a raised to the power x ln a du by dx. Now it is ln u log d by dx of ln u. That is 1 by u du by dx. 1 by d by dx of log log base au is equal to 1 upon u log a into du by dx. Partially we have done it earlier. Now this is the gist of the formulas. Your fx function will be with fx and your derivative will be denoted by f dash x. If your first function, first form is a fx, so its derivative will be a f dash x. If you have two functions in addition, so they will be differentiated individually. If you have fu and you have to find f dash x, then it will be f dash u into du by dx. That is chain rule. Derivative of constant is 0. Anything which is in terms of x raised to the power n, that is the universal formula, or it is known as power formula. It is again given over here in this box form. It is x raised to the power ns and x raised to the power n minus 1. Un, it will be n, what we have done, and u raised to the power n minus 1 into du by dx. If we have two functions in product form, first function as it is, derivative of second function, plus second function as it is, derivative of first function. If we have the form of a problem in terms of u by v, but in that case we have to apply quotient rule. That is the square of the denominator. In the numerator part, you will get the denominator into derivative of numerator minus numerator into derivative of denominator. Derivative of e raised to the power x is e raised to the power x. Derivative of e raised to the power u is e raised to the power u into du by dx. Derivative of log x is 1 by x, and derivative of a raised to the power n is a raised to the power a raised to the power n log a. But these are the standard formulas. Now, another function straight away till now, we were talking about x, terms with x1, x. Now here, what has happened? We will be getting x and y together in the same problem. If we are given a relation fxy equal to 0, you can see that it is now fxy. It is not possible to express y in terms of x or vice versa. Then that relation is called implicit function. And we have to determine dy by dx in such a situation. We differentiate both sides of the equation and obtain an expression for dy by dx from resulting equation. But this is the theory. Now we will see how the problem will be solved. See to it. Your problem is x cubed plus y cubed is equal to xy. By any method, we cannot find or we cannot convert this expression in terms of y and x individually. Straight away, we will be differentiating. Now you can see derivative of x cube. Of this first step is what? How it is written. Derivative of x cube plus d by dx of y cube is equal to d by dx of xy. Now you can see that there are two functions x and y. They are in multiplication form. We have to apply product rule. Straight away, what we will be doing? We will be differentiating x cube. It will be 3x squared. Plus, when you will be differentiating y cube, it will become 3y squared into dy by dx. Plus is equal to. On the right hand side, you can see there are two things, x and y. So straight away, what we will be doing? We will be using the relation of u and v. First function as it is, derivative of y plus y as it is, derivative of x. Derivative of x is 1. So now what we are going to get? 3y square dy by dx minus, bring this all dy by dx on one side. So it will be minus x dy by dx is equal to y. Bring this 3x square on the right hand side. So signs will change. Y is equal to minus 3x square. Now take dy by dx common. You will be left with 3y square minus x. On the right hand side, you will be getting y is equal to y minus 3x square. You have to find dy by dx. Bring the coefficient to the denominator. Your solution will be dy by dx is equal to y minus 3x square upon 3y square minus x. This is how the derivative of an implicit function is found. Implicit function is that function in which x and y, they both occur together, and by any means they cannot be separated. Separated means y terms cannot be brought to one side and the x terms on the other side. So what we will be doing, we will be simply applying differentiation, and we will be differentiating y with as dy by dx. Now you can see over here something fascinating, because as the problem is, we have to apply so many things. You can see that the problem is x under root 1 plus y under root 1 plus x is equal to 0. So straight away what we can do, we can bring this the second part on the right hand side. So now your problem will be x under root 1 plus y is equal to minus y under root 1 plus x. To make it simpler, what we are doing, we are squaring both sides. If we are squaring both sides, you can see to it under root has been removed. When we will be squaring both sides, the under root will be removed. Now you are left with x square into 1 plus y equal to y square into 1 plus x. Club them, multiply them, open the bracket. Simplify as much as you can. Now in the last line, after simplifying it and taking things common together, you can see that what we are having. We are having x minus y into x plus y plus xy equal to 0. That means x is equal to y. Is the first thing, so derivative will be 1. Now, on the other side, what is there? X plus y plus xy. Now, what we will be doing? We will be differentiating it. So what we are going to get? When we are joining these things, so we are having this y is equal to x upon 1 plus x. We have to differentiate this after simplifying this, because we can take y common and we will be left with 1 plus x, and this x, 1 plus x will come in the denominator. Here it is. So your y will be minus x upon 1 plus x. We have to differentiate it, so it will become dy by dx is equal to d by dx of whole thing. Now you can see this is in u by v form. So we will be applying quotient rule, squaring the denominator, bringing this denominator in the numerator into d by dx of x is 1 minus derivative of this into 1. So it will be x into 1. You are left with this one. And don't forget about this minus. This minus will come over here. Normally, while the learners are making calculations, they normally leave or forget this y, this minus sign, and which creates whole of the problem. Depending, keeping an eye on the problem, we can simplify. Now see, something very unusual. This is a relation ax squared plus 2hxy plus dy square plus 2gx plus 2fy plus c equal to 0. We have to differentiate it. Nothing to do with it, nothing. First of all, yeah, you should take x and y terms. Rest everything will be a constant. Now the thing is that how to segregate them. As far as this ax square is concerned, so it can be written in this form. Fine. Plus 2h is constant into d by dx of what is remaining, x and y, plus d by dx of y square, plus 2g d by dx of x, plus 2fy dy by dx. The derivative of y is dy by dx, plus d by dx of this c. Okay, and is equal to d by dx of c. Now, how to proceed? We have found out what has to be differentiated. Derivative of x square will be 2ax. Keep this 2h over here, and this is product rule, application of product rule. X dy by dx plus y, close the bracket, plus derivative of 2y will be, y square will be 2y dy by dx. So you can make 2dy dy by dx plus derivative of this x will be 1, so it will be 2g plus 2f dy by dx as it is, plus derivative of constant is 0 and derivative of 0 is 0. Fine. You are now left with this. Open the bracket and take dy by dx together. So when we will be taking dy by dx together, so you will be having 2hx plus 2by plus 2f bracket close plus 2ax plus 2hy plus 2g. Bring this on this side and then bring this to the denominator. And in the meantime, you can take 2 common from the numerator and denominator. Everything will be without 2 now. So that means your answer will be minus ax plus hy plus g upon hx plus by plus f. Now, differentiation using logarithm. Logarithm is applied basically where the powers cannot be reduced. Now we will see how powers cannot be reduced. But where are the problems where the powers cannot be reduced? Anything which can be written as y is equal to fx raised to the power gx. So what is the exact method of solving it? This is the method what I am showing you. We have to apply log on both sides. So when we will be applying log on both sides, so it will become log y is equal to log fx raised to the power gx. In the next step, what will happen? The power what you are having as gx will come in front of log fx. So this will be converted to this form. After the application of logarithm will be converted to this form. Now we have two functions. That is, first one is u and the second one is v. We will apply product. Now, what are the different properties of logarithms? Log mn is equal to log n plus log n. Log m by n is equal to log m minus log n. Log m raised to the power n is equal to n log m, what we have applied over here. Log e raised to the power x is x, and log e is 1. These are the standard results, what we will be using for converting a complex problem into a simpler form. This is the method when we apply logarithms on both sides. This is the function. This will become log y is equal to log of all this, and we will be applying this property, and we will be bringing this power in front of log x. Now we will see how it is solved. Your problem is y is equal to x raised to the power x. X cannot be reduced. So what we will be doing? We will be applying log on both sides. So it will become log y is equal to log x raised to the power x. We will apply again the property. So this will become log y is equal to x log x. X log x are two functions in the form of u by v. We will write differentiating both sides. Derivative of log y will be 1 by y dy by dx. That is standard, we cannot change. Is equal to, now we will apply product rule. First function as it is, derivative of log x, plus second function as it is, derivative of first function. Now in the next step we will be solving this. 1 by y dy by dx is equal to x into derivative of log x is 1 by x, plus log x into derivative of x is 1. We are with 1 plus log x. On the left hand side, we have to find dy by dx. So what dy by dx will be? Dy by dx will be equal to y into 1 plus log x. Our question was in the terms of x. So we have to replace this y with x. Your y is x raised to the power x. Therefore, your answer will be dy by dx is equal to x raised to the power x into 1 plus log x. This is the property what we have used and what we will be using and what is to be used. Now see, another composite problem, the same method will be followed. You have to differentiate x raised to the power of y is equal to y raised to the power x. Here we can see that power cannot be reduced. Then what we will be doing? We will be taking log on both sides. It will become log x power y is equal to log y power x. By using this, we will be changing this y log x is equal to x log x. Here on left hand side as well as on the right hand side, you can see there are two functions of y and x and y. We will be applying product rule on both sides because now we have to differentiate. First function as it is, derivative of second function, plus second function as it is, derivative of first function, is equal to first function as it is, derivative of second function, plus second function into derivative of first function. Your first function over here is y, and your second function is log x. But on the right hand side, your first function is x, and the second function is log y. Now you can see. Derivative of log x is 1 by x. Log x dy by dx, it will remain as it is into x into log derivative of log y is 1 by y dy by dx plus log y. Now bring all logs on one side and another numbers on the other side. So we can see that it will become log x minus x by y dy by dx is equal to log y minus y by x. Now we want dy by dx, we will bring this down and we will solve. So we will get the answer in this one. The problem was this and your solution is this. But keep one thing in mind. Your answer will remain as it is because we cannot replace any of the y with x anyway. Now you can see a very composite function. Y is equal to x plus 1 raised to the power 10 into x plus 5 into x plus 6 upon x plus 7 raised to the power 2. We cannot apply quotient rule or product rule simultaneously in this problem. Now, what we can do, or what we are supposed to do, we will apply log on both sides. So that will become log y is equal to log of this function. Now you can see that in the numerator there are 3 brackets, and in the denominator we have a single. So when we will be applying log on the right hand side, what we will see, these 3 products are in products. So how we will be writing? First as it is plus log of second plus log of third. When they are in products, when the log is applied, it will become in the addition form. Now this is in denominator, it will become minus and complete with log will come. Now we will, in the next step, we will bring this 10 in front of this by applying this relation. Plus log 5 plus log 6 and this 2 in front of this. Now we will apply derivative on both sides. Log y will become 1 by y dy by dx is equal to log x plus 1 will be 10 upon x plus 1. Nothing to do because we have a linear power. Log x plus 5 is 1 by x plus 1. Log 1 x plus 6 is 1 upon x plus 6. Minus 2 as it is. Log x plus 7 will be x plus 7. Okay. Now your dy by dx will bring this y and plug this. Now here we will be replacing y with the parent problem. This is the complete answer. Don't do anything else. In this particular problem, we have applied all the 3 relations of logarithm in multiplication form, power reduction, as well as division. All the 3 things have been applied in this particular problem. Another type of problem is that you can see over here. It is y is equal to 3x squared plus 5 raised to the power 1 by x. Again, the power cannot be reduced. We will be taking log on both sides. So your problem will be log y is equal to 1 by x into log 3x squared plus 5. Now again, when we will be differentiating it, you can see there are 2 products. 2 terms, 1 by x and log 3x squared plus 5. In that case, your derivative of log y will be 1 by y dy by dx is equal to first function as it is, derivative of second function, plus second function as it is, derivative of first function. This is basically the product rule is. Now we have to apply this. After application, what will happen? 1 by x as it is, log. This is the term. Derivative of 1 by x is minus 1 upon x square, which can be written as minus x raised to the power minus 2. We have to find dy by x. After simplification, what will happen? You will be left with this. Now you have to bring this y over here. So y will come over here. The problem was given to you in terms of y. So replace this y with this. This is the solution. Now, derivative of inverse function. Let y is equal to fx be a function of x. And suppose that we can solve the equation of x in terms of y. So we write x as a function of y, which will be x is equal to g of y. Then g of y is called the inverse of y. If y is equal to fx is differentiate function at x such that f dash x is not equal to 0, then x is equal to gy is also differentiate at the corresponding value of y, and dy by dx will be equal to 1 upon dy by dx. Now the thing is this, how it is applied. You have to find dy by dx of the following. First of all, what we will be doing? We will be differentiating it. Since you can see that it is in the form of u by v, we will be differentiating it by applying u by v concept. Denominator square, denominator into derivative of this numerator minus numerator into denominator, derivative of denominator. We will open it up, we will get this. But we have to find dx by dy, thus reciprocate. This power will come in the, your answer will be x plus 1 raised to the power 2. Now comes parametric function. In the process, rather than defining x and y in terms of one another, we define these in terms of another variable t, which is known as parameter. So we have x, thus we will straight away see x is equal to ft and y is equal to gt. But you have to find dy by dx, so we will be applying chain rule. Now you can see what is happening. Here x is equal to ft and y is equal to gt, differentiated. This will be dx by dt and this will be dy by dt. But you are supposed to find dy by dx. So first of all, dy by dt upon dx by dt has to be calculated. But you have to remember one thing, dx by dt should not be 0. If dx by dt is 0, then we cannot find out the derivative. You can see you have to find dy by dx of the following function. Your y is equal to t cube and x is equal to t square. So you will be differentiating y in terms of t. So it will become dy by dt, which will be 3t square, and your dx by dt will be 2t. But you have to find dy by dx, so it will be dy by dt upon dx by dt, which will be 3t square upon 2t, which will be equal to 3 by 2t. This is how derivatives of parametric functions are evaluated. Now you can see a composite function, a parametric function which is in form of numerator and denominator. You will start with dx by dt. So dx by dt will be this denominator square into denominator into derivative of 1 minus t minus 1 minus t into derivative of 1 plus t. That is t. That is 1. So we will get dx by dt is equal to minus 2 upon 1 plus t square. And on the other side, we have y is equal to 2t cube plus 4 power t. Now you see 4 power t is there. Don't get confused. We have a formula of a raised to the power n. So dy by dt will be 6t square plus 4t log 4. Now you have to calculate what? Dy by dx. So it will be dy by dx will be equal to dy by dt divided by dx by dt. Write up all the values over here. And you have to, after solving it, you will get the derivative. This is how dy by dx of a parametric function and component function is. Now we come to the application part of the differentiation. Now the question is how and where are they applied? That is the basic. We will be differentiating and we will be finding the values. Now how these values are found. If fx is differentiable function of x, then f dash x or dy by dx is the first derivative or first order derivative of fx with respect to x. Since the derivative of function is also a function, another derivative can also be found. The second derivative or the second order derivative is the derivative of the first derivative of the function, and it is denoted by f double dash x. The function is fx. The first derivative is given by f dash x, and your second derivative is given by f double dash x. And if the third derivative is also required, normally we don't be needing it, but in some cases, if it is required, it can be written as f triple dash x. Now you can see your fx is 5x power 4 plus 6x square plus 2x plus 1. The first derivative will be 20 plus 20x cubed plus 18x square plus 2x. Your second derivative will be 60x square plus 36x. Your third derivative will be 120x plus 36. You can see how successive derivatives are formed. Now the thing is that after the derivative has been formed, how they are applied. First of all, we will start with interpretation of derivatives of different parts. The first derivative of the function, that is y is equal to fx or dy by dx, measures the rate of change of y due to the change in x. It gives the stripe of the curve at a point. Now listen to it very carefully what is happening. If the first order derivative is positive, that is dy by dx is greater than 0 at a point, then it implies that y increases for a small increase in the value of x. Now, the second part is if dy by dx is equal to 0 at any point, it implies y does not change for a small increase in the value of x. Thirdly, if it is dy by dx is less than 0, that means it becomes negative. Then y decreases for the same small increase in the value of x. First concept of first derivative has been seen. Now we move to the second derivative. Your function was y. First derivative will become dy by dx, and your second derivative will be d square y upon dx square. If second derivative is greater than 0, it will be increasing slope. And if your second derivative is less than 0, that will be decreasing slope. Now, how we will be finding increasing and decreasing regions for an function? Broadly speaking, a function, say fx, is increasing when y increases as x gets larger. That is, looking left to right. And fx is decreasing when y decreases as x gets greater. Such functions are of interest to us for determining the rate of change of variable. For example, we would like we will be interested to know the speed of a car or rate of growing and declining population of a country. What happens in increasing function? A function fx is said to be increasing in the interval a b. If y increases as x increases, the function increases in a. If x1 and x2 they all belongs to a and b, and x2 is greater than or equal to x1, then function of x2 must be greater than equal to function of x1. Now you can see over here, the function is said to be increasing in the order other derivative is greater than 0. That means it is moving. Now you can see when the graph is increasing, the curve y is equal to fx increases from left to right as we the point is x is equal to q. It's coming up. Now you can see what are the exactly the reverse will happen in decreasing function. Here x2 will be greater than or equal to x1. You can see at respective value of x is equal to q, the graph is falling down. Now see the application. Find the interval in which the function is increasing and decreasing. The function is fx is equal to 2x cubed plus 9x squared plus 12x minus 1. Differentiate it. You will differentiate it, you will get 6x squared plus 18x plus 2. Take 6 common, you will be left with x squared plus 3x plus 2. Split the middle term and you will get the two factors as x plus 1 and x plus 2. Now, if f dash x is greater than 0, okay, your f dash x is 6 into x plus 1 into x plus 2 is greater than 0, then what will happen? You just take a number which is less than minus 2. When you will be taking that number, what will happen to the derivative? It will be a positive number because negative and negative becomes positive. A positive number multiplied by 6 will be positive. Therefore, we can say that if x is less than minus 2, it is a increasing function. And now we take another value which is x is greater than minus 1. So in that case, both the brackets will be positive and it will be increasing. Now, what is the correct way of writing the answer? From minus infinity to minus 2, union minus 1 to infinity. This is the correct way of writing the answer. Similarly, we are taking to the second part of it for the derivative for the decreasing period. What we will do? We have already calculated the derivative. Now we will change the sign. That means f dash x will now be less than 0. So similarly, we will be taking two values, and if we take a value between minus 2 and minus 1, So we will get a plus sign and a minus sign, which will be plus into minus is minus. That means it will be a decreasing function. So how to write the solution? Fx is increasing when x belongs to minus infinity to minus 2, union minus 1 to infinity. And f dash x, fx is decreasing when x belongs to minus 2, comma minus 1. Now, the revenue function of a firm is given by R is equal to 8,000, 8 lakhs plus x minus 300 raised to the power 2. We have to determine the value of x for which the total revenue function is increasing and decreasing. So what we will be doing? We will be differentiating R. When we are differentiating R, that will become R dash is equal to 2 into x minus 300. This is our derivative. If a function is increasing, the derivative will be greater than 0. And if it is greater than 0, so it will be a value which is greater than 300. And if second derivative is less than 100, less than 300, if less than 3, it will be decreasing. So what we see, the revenue function is decreasing for x is equal to 0 and lying between 0 and 300. That is 0 less than equal to x less than 300. And it is a stationary value is at x is equal to 300. Now come maxima and minimum. Maximum and minimum in their plural form are known as maxima and minimum. Maxima or minima of a function is the largest or the smallest value of a function, defined either within a given range, the local or relative extremes, or on the entire domain of a function. Maximum means upper bound or the largest possible value. The absolute maximum in the function is the largest number contained in the range of the function. Now, what is the method for finding local extreme values? First of all, find f dash. Second step is to find the critical value of a function that can be found by putting f dash x is equal to 0. Third step, each critical value of x, say x is equal to a, determine the sign of the first derivative. If sign of the first derivative f dash x changes from positive to negative as x increases through, then the function attains a local maxima at x is equal to a. And if f dash x changes from negative to positive as x increases through a, then the function attains local minimum at x is equal to a. Fourth step is if f dash x does not change its sign as x increases through a given, then there is no local maxima or local extrema at extreme at x is equal to a. Such point is known as point of inflection. Now comes the second derivative test for the local extreme values. A function f(x) is said to be maximum if and f double dash x is less than 0 at a critical value of x is equal to a. You can see that second derivative is, if second derivative is negative, function is maximum. And if second derivative is positive, function will be a point where second derivative is equal to 0 and third derivative is not equal to 0. That is known as the point of inflection. Now, you can see to this graph. This is basically a graph of a single function. What is happening over here? Suppose it starts from here. It's moved like this. After obtaining this value, that means a dy by dx equals 0. It is changing its direction. It's coming down. Over here. Now from here again, it is changing its direction. And here at this point also, dy by dx is equal to 0. Now moving up, again moving down. So what we see, mathematically what we see, if derivative is greater than, it is moving up, and if it is greater than less than 0, it's coming down, and when it is again greater than 0, it's coming up, and when again it is less than 0, it's coming down. This is how it is shown on a single graph. Second derivative measures the rate of change in the marginal function. If the derivative is 0, indicating a zero slope and hence a plateau in the function, while second derivative is negative, it means the function is moving up and the plateau and should have been in a relative maximum. If the first derivative is 0 and the second derivative is positive, it means that the function is moving upwards from a valley and the function has a relative maximum. A point at which the first derivative equals to 0 is called as critical value or a stationary value or an extreme value point. If the second derivative is equal to 0, then put the third derivative does not equal 0. Then the critical value is neither maximum nor there will be a point of inflection at which the function alters its rate of change. What are the steps for finding maxima and minima using second derivative? First of all, find first derivative. Second step, put f dash x equal to 0 and find the value of x. Third step, find the second derivative of the function. Now substitute the critical values in the second derivative. After the substitution of critical values, second derivative can be positive, negative, or zero. These things can come. If second derivative is greater than 0, it is local minimum. And if second derivative is less than 0, it is local maxima. And if second derivative becomes 0 and the third derivative can be either 0 or non-zero. The information regarding maximization or minimization of a function can only be gathered at an even ordered derivative, whereas information regarding point of inflections can be collected at an odd order derivative. Now, how higher order derivatives are written? We have first derivative as f dash x. Second can be written as f double dash x or d2y upon dx square. Third can be written as d cube y upon dx cube. Fourth, d4y upon dx4. And another term can be written as d and y upon dx. Now you can see fx is equal to 3x power 5 minus 2x cube plus 14. You have to find the first derivative. It will be 15x power 4 minus 6x squared. Second derivative will be 60x cube minus 12x. The third derivative will be 180x squared minus 12. So on we go on moving. Now you have to find the point of local maximum and minimum of the function. We have the function 2x cubed minus 15x squared plus 36x plus 60. Straight away, without doing anything, find out the derivative. And after derivative, reduce it to the simplest multiple function. Here you will see that you have your derivative as your derivative as 6 into x minus 2 into x minus 3. That means you have two values, 2 and 3 to study. Less than 2, more than 3, and between 2 and 3. If you are taking x less than 2, your f dash x will be greater than 0. And if you are taking any value between 2 and 3, your f dash x will be less than 0. And if you are taking any value greater than 3, your f dash x will be greater than 0. This is normally what we can see. Now since fx changes sign from plus to minus as I increase through 2, therefore x is equal to 2 is the point of local. Similarly, f dash x changes its sign from negative to positive as I increase by 3. In that case, that will be point of local. Now we will use second derivative test to find the points of maximum and minimum. Your function is x power 5 minus 5x power 4 plus 5x cubed minus 18. First of all, find derivative. Your derivative will be 5x squared into x minus 1 into x minus 3. Putting x is equal to 0, that means derivative is equal to 0. We will get x is equal to 1, x is equal to 3, and x is equal to 0. Study the nature of the graph. That means we will be finding out the second derivative at these values. Second derivative at 1 will be negative. That will be local maxima at x is equal to. And by putting 3, what we are getting, it is greater than 0. Therefore, it will be a local minima at x is equal to 3. Now we will see the second derivative. Second derivative will be greater than 0. Since a third derivative will be greater than 0. Since the third derivative is an odd number, function has already a maximum value, not a minimum at x is equal to 0. Hence, function has point of inflection at x is equal to 0.
Thank you so much, sir.
And I'm here only just a minute. I'm changing the slide.
What, sir?
I'm changing the slide. I'm here
Okay,
only.
okay. Okay. Yeah, I'm here.
Well, we are proceeding further. So I'm just changing the slide.
Okay, thank you so much.
क्लास खत्म हो गई
नहीं.
आ सकती हूँ
This is what we have done. Now we will be moving further to unit 9, that is application of derivatives. We are aware of what first derivative is, what second derivative is, how the study of second derivative is done, and what are the conclusions what we get. In the present unit, we extend differentiation techniques for applying to select business and economic themes. Basically, an attempt is made here to learn the use of derivatives to understand the rate of change as well as the change in rate of change, which is the cornerstone of marginal analysis in economics as well as in business studies. Demand function and supply function. In microeconomics analysis, it is postulated that demand and supply are functions of price, while the quantity demanded is related to price inversely. In case of supply, it has a direct relationship with price. Because of such a proposition, we have a downward sloping demand curve and upward sloping supply curve. For simplicity, we often assume that the demand curve and supply curve for a good or a service to be linear line, although another non-linear types are also considered. The consequent slopes of demand and supply curves are respectively negative and positive. A linear equation is of the form y is equal to mx plus c, where m is the slope of the line and c is the y-intercept. We can model a demand function as y is equal to minus ab plus q, or the inverse demand function of y is equal to ap plus q, where p and q represent price and quantity respectively. In such a format, we move the price to the horizontal axis and the quantity on the vertical axis, and we think of quantity demanded or supplied as a function of price. In the event of presenting inverse demand function, we consider quantity in horizontal axis and price in vertical axis. Now, we will see the use of this form when we come to the derivation of marginal revenue. If the slope is negative, in case of normal demand curve, which slopes downward. Similarly, a supply curve is modeled by another linear equation in the form of y is equal to Cp plus d, where C is the slope of the supply curve and with a positive sign. The slope of demand curve. In case of equation of demand curve as y is equal to minus ap plus q, differentiating q with respect to p, we get dy by dx is equal to minus a. The slope is negative a, and it gets the rate of change of quantity demanded in response to the change of the price. See that the downward sloping demand curve is represented by a negative slope. Now, what are the reasons for this feature? Substitution effect. Consumers will substitute other goods to buy more or less according as the price falls or rises. Second effect is income effect. Rise or fall in the real income as price falls or rises. Third one is law of diminishing utility. At a lower price, consumers are willing to consume more as they compare the price with the satisfaction and is derived from the consumption of that. Now, slope of supply curve. It will be positive. Considering the equation y is equal to Cp plus d above and differentiating q with respect to p, what we are going to get dq by dt is equal to c, which is positive, which indicates a possible relationship between quantity supplied and price. Now, what are the reasons? Profit motive. When rise in price following an increase in demand it becomes more profitable for business to increase their output. Second reason is production and costs. Firms' production cost tends to rise as output expands. Consequently, higher prices needed to cover these extra costs of production. Third one is incentive for new entrants. Higher prices may create an incentive for other businesses to enter into the market, leading to an increase in total supply. Now comes elasticity, demand, and supply functions. Elasticity refers to the responsiveness of the independent variable of a function to change in the independent variable. It is measured in terms of percentage, changes instead of absolute. For example, if we consider the percent change in a variable x with, and we can write as the percent change in x is equal to change in the variable x upon original value of the x. Or we can say as delta x upon x. If concerned with elasticity, then we can say that elasticity of y with respect to x. And we need to find the ratio of the percentage change in y to the percentage change in x. Elasticity will be percentage change in y to percentage change in x. That will be. Sometimes the elasticity is defined with a negative sign, while at others in absolute values. For convenience, let us stick to the sign to emphasize the nature of the percentage. When elasticity demand and say greater than -1, it indicates that a percent increase in x corresponds to a greater percentage decrease in y. In such a case, we would say that the variable y is elastic with respect to variable x. As elasticity between -1 and 0 indicates a percent increase in x corresponds to a smaller percent decrease in y. So the variable y is inelastic with respect to the variable x. If the elasticity is -1, then the percent increase on x corresponds to an identical percentage decrease in y. In that case, the variable y is said to be unit elastic with respect to variable x. Price elasticity of demand, that is PED. Such a concept helps us to explore the responsiveness of the consumer demand for some product to change in the price of the product. If the price of the cup of coffee were to increase, the quantity sold will be influenced. To see the point, suppose in 2016, Nestle increased the price of coffee from rupees 4.95 to rupees 5. Due to such a change, the demand for coffee dropped from 440 units per day to 438 units per day. So what is the change? Delta P upon T will be what is the price change? Price change is 5.5 minus 4.95. And what was the total price? Actual price initially that was 4.95. It becomes 0.01, which is almost 1%. Now what was the change in the quantity? The percentage change in the demand, that was dQ upon Q is equal to 438 minus 4.244. That becomes negative 0.0. Almost 45 negative, which is almost 45 0.45 decrease in the quantity demand for coffee. Now what is the price elasticity? your price elasticity with the percentage change in Q upon percentage change in P. That is negative 0.0045 divided by negative 0.01, which comes out to be 0.45%. So what conclusion can be drawn? The result shows that 1% increase in price corresponds to 0.45% drop in demand. Of course. On the other hand, we may also say that 1% drop in price corresponds to a 0.45% increase in demand. It's how used. Now, mathematically, how it is expressed. Taking into account the relationship between demand and price or in a functional form, we can use derivative of the demand function to calculate the price elasticity of demand. If we write that the change in price is being from P to delta P, and correspondingly the quantity is changing from Q to delta Q, then by definition of the elasticity we can say that ED is equal to percentage change in Q upon percentage change in P. Now the thing is that how this percentage change in Q can be measured. That is delta Q upon Q divided by delta P upon P. When we will be reforming them, so it will become P delta Q upon Q delta P. This is the term relationship. It may be noted that delta Q upon delta P represents the average rate of change of demand Q with respect to price P. If we assume the change in price is small, we can replace the average rate of change with the instantaneous rate, that is dq by dt. Depending upon if the function demand function is q is equal to fp, then we can write price elasticity as v by q into dq by dt. Or if we define point price elasticity of demand as a point P naught Q naught on the demand curve as P is equal to dq upon dp into P naught upon Q. It is basically depending upon what the condition is given to you in the problem. Now we will see whatever we have heard, how it is applied into a particular problem. To find the point price elasticity of demand Q equal to 15,000 minus 15P. Given this demand curve, we need to find out the price elasticity of the demand at two different prices, P is equal to 100 and P equal to 10. Now we take the derivative of the demand function when it is expressed as Q as a function of P. Since quantity Q goes down by 50 each times per price by 1 unit, we get delta Q upon delta P equal to minus 50. To find the quantity demanded at each point level, we consider the price quantity combination of 100, 10,000, 10, 14,500. ED will be minus 5 in the first case, and ED will be negative 0.034. The result obtained shows that both elasticities are negative. That implies a downward slope demand relationship. Moreover, they are relatively more elastic. Another concept is of income elasticity of demand. The income elasticity of demand YED measures how effect of the change in the consumer's income on the demand for a specific product. It is defined as the ratio of proportionate change in quantity demanded due to the proportionate change in the income, where there is a positive relation between income and demand in case of normal growth. Hence, sign of my income elasticity and demand elasticity is how this can be written as in mathematical relation. EY is equal to proportionate change in demand upon proportionate change in income. The demand function will be delta Q by Q and by your income function will be delta Y by Y. Reforming them, it will become Y by Q into dQ by dy. So rate of change, the case of for instantaneous change of income, it will become Y by Q into dQ by dy. Now we see y is equal to x, x is equal to 4y square, where x is the quantity demanded of a good and y is the consumer's income. Find the income elasticity of demand. The function is x is equal to y square differentiated. When you are differentiating it, you are going to get dx, it will be x1 is equal to 8y dy by dx. Your dy by dx will be 1 upon 8y and your dx by dy will be 8. So going back to the relation, dy is equal to 8y into y upon 4y square, which comes out to be 2. The higher the income elasticity of demand for a specific product, the more responsive it becomes to the change in the consumer's income. It is a positive with number of 2. Now we can measure the income elasticity of demand for different products by categorizing them as inferior goods and normal goods. Now you can see the point elasticity of demand. ED is equal to dQ upon dP into P upon Q. If ED is negative for a downward sloping demand curve, inelastic demand if ED is less than 1, unit elastic demand if ED is equal to 1, and elastic demand if ED is greater than 1. But these are the interpretations what we do after solving the problem. Normal goods. The YED for a product can be elastic or inelastic based on its category, whether it is an inferior good or a normal good. When YD is more than 0, the product is income elastic. Normal goods have a positive YED. That is, when the consumer's income increases, the demand of these goods also increases. Inferior goods are goods so because these have superior alternatives. Such goods have a negative income elasticity. That is, YED is less than 0. If the consumer's income increases, the demand less for these goods. If sign of income elasticity of demand is negative, then the commodity is inferior. Now, how these all relations are elasticity of supply estimated by EAS is defined as the ratio of proportionate change in quantity supplied to where proportionate change in supply will be negative delta QS upon QS whole divided by delta P upon Q. And you will be determining them, it will become P dQS upon QS into dQ. Now we will see. For a supply function x equal to 5 plus 2p square, find the elasticity of supply at p is equal to 2. We have to differentiate it. The dx by dp will be equal to 840. Now ES will be d upon x into dx upon dt. Substituting all the values, you will get 4p square upon 5 plus 2p where p is equal to 2. Your ES will be 16 by 30, which is greater than. I will be concluding here only, and in the next session we will finish this up and we will start with the statistics. The part B is statistics. So we will be moving further in the next session. On this, we will be concluding it and we will be starting statistics. In the meantime, please go through your study material and find out the problems on the topics what we have discussed, and to the remaining part what has been left. Can I conclude now? Are you there? Sayyid Abbas, are you there?